Hi everyone, welcome. So this is the first chapter, Basic Physical Chemistry of UPSC Geochemist and ntpc. This chapter is a common chapter for both Geochemist and ntpc, and also this Basic Physical Chemistry chapter is very important for the aspirants who are preparing for all competitive examinations. Either you are preparing for GATE, NET, NTPC, Geochemist, or for any other competitive examinations, this basic physical chemistry chapter is very important. Actually, we aspirants generally neglect this chapter without knowing these fundamental things of physical chemistry. We generally try to study every other thing, but without knowing these basic fundamental things of physical chemistry, it is very difficult to understand other part of physical chemistry. So that's why I'm starting this chapter. For suppose if you take if you take the gate question, in gate question generally examiner will ask you to report your value up to 3 decimal places, up to 2 decimal places, up to 4 decimal places. Here generally most of the aspirants struggle to find out that particular uh, digits, right? Up to which digit they have to report. Generally most of the aspirants struggle here. That's why I'm just starting this chapter from the fundamentals, from the basic level itself. So just focus on this, and I will try to complete whole syllabus of geochemist as I will try to complete not whole syllabus, actually I will try to complete maximum syllabus of geochemist. Okay, I will try my level best. So please be sincere and follow every video. Okay, and if you people think that you have more time to complete the syllabus, no, you don't have more time. Again I'm telling you, you have very less time, right? Especially if you take the geochemist, at least you have to give 1 year time, 1 year dedicated time to complete the syllabus of mains and prelims. I'm going to complete mains and prelims both syllabus. I will try to complete. Okay, don't worry. So follow these lectures sincerely. I will try to uh, do questions also. I will try to give you a practice questions also at the end of the every video. So please practice them, and additionally I will try to provide you some practice questions in the telegram also. Okay. Okay, so let us start. First of all, the first topic, here I'm going to give you one example. So the first example here, 5 point, just wait. Okay, so here 5.3624. Okay, 5.3624. I am asking you to provide this. For suppose you got this value after calculation. After calculation, you got this value. Now I am asking you to provide your value up to 3 digits. Up to 3 digits means here, from here, okay, up to here. I want you to provide your value. What you have to do? Simple. First of all, you have to see this value. Okay, you have to provide up to here, so you have to see this value. For suppose after 6 means after third digit, after third digit, if this value is less than 5, if this value is less than 5, you don't need to change anything. You have to report your value as 5.36 only. Clear? Clear? Okay, another example. For suppose if I give you 1.2732, 1.2732, tell me, provide your value up to 3 digits, up to here. Then to see next value, 3. 3 is less than 5, less than 5, so you have to provide your value as it is, that is 1.27. Clear? Okay. For suppose if I give you 5.3674, 5.3674, Then provide your value up to 3 digits. What you have to do? See this value 7, it is greater than 5. So whenever this value, after this value is greater than 5, what you have to do? You have to increase by 1. Why? Just remember like this. Here it is increasing. So this number also has some ego. You are increasing, so I will also increase. You are increasing, so I will also increase. Okay. So this 5.36 will increase by 1. Okay. So it is greater than 5. That means high. So I will also high. So 5.37 you have to report. You have to report 5.37 you have to report. Okay. Whenever you have greater than 5, you have to increase by 1. Whenever you have less than 5, you don't need to increase, just report the same value. Okay. Next, for suppose 1.2762, provide your value up to 3 digits. You have to see this value 6 greater than 5, so you have to increase by 1, that is 1.28. Okay. If I ask you to provide this same number up to 2 digits, that means up to here only, what you have to do? See the next number. Next number is 7 now. Next number is 7 now. So 7 means greater than 5. So you have to increase by 1. That means your answer now is 1.3. 1.2 plus 1, 1.3. Right. So this number you have to increase by 1. Right. Next. For suppose I'm taking this one. 1.2732. I'm asking you to provide up to 2 digits. Okay, up to 2 digits. Then you have to see this 7. You have to see this 7. 7 means greater than 5. So I have to increase by 1. That is 1.3. 1.3. Right? Okay. Okay. So next important thing. First, suppose if we have less than 5, greater than 5, we have to do like this. First, suppose if I give you the number like 5.36521, I am asking you to report your value up to 3 digits. What you have to do? You have to see the next number. Next number is 5 here. What you have to do? It is not less than 5. It is not greater than 5. It is exact 5. So whenever you have exact 5, you have to see the preceding number. That means you have to see this number, preceding number of this 5. If it is even number, what you have to do? If it is odd number, what you have to do? Tell me. Simple. If it is even number, just to remember, lo it is as plus, it is as minus. So plus minus attractions, so you don't need to change anything. So report as 5.36 only. Okay. If the preceding number, if it is 5, see preceding number. If preceding number is even, then you don't need to change anything. Report as it is. If your preceding number is odd, for suppose 5.37521, in place of 6 I have 7. What you have to do? Here 5. So see the preceding number. This number is odd. Whenever it is odd, for suppose this is odd, this is odd, same nature. So minus repulsions or plus repulsions, like in chemical bonding, right? So it will not exist. Immediately it will turn into even number. That means you have to increase this number as 1. That is 5.38. 5.38. Right? 85, even odd, now exist. So that's why if it is odd, you have to increase by 1. If it is even, then you have to report as it is. Okay. So this data is very important. Remember, because after calculation in your GATE, geochemist, ntpc, in every exam, examiner will ask you to report up to 2 digits, up to 3 digits, up to 4 digits, like that. Okay. So you have to report your value like this. Clear? Okay. Next important thing. For suppose I am asking you scientific notation. How you have to write the scientific notation? For example, I am giving this 2.2 into 10 to the power of 4. 10 to the power of 4. Okay. This is multiplying with 3.3 into 10 to the power of 5. Okay, how you have to do this question? Simple. This 2.2 and 3.3 multiply 2.2 into 3.3. You will get some value. You will get 7.26, right? And you have to this 10 power of 4, 10 power of 5 multiply base same. You have to add powers. So whenever you have the base same. So whenever same base, you have to add the powers. 4 plus 5, 9. So into 10 power 9. So this is nothing but your scientific notation. Okay. If anyone asks you to provide in a scientific notation by giving this, you have to tell this value. Clear? And for suppose if I give 900, what is the scientific notation of this? How you have to write? 9 into 100, 900. That means I can write 9 into 100 means 10 square. This is scientific notation. For suppose if I have 90, that means 9 into 10 I can write. That means 9 into 10 power 1. This is scientific notation. You have to report like this. Clear? Okay. Next, for suppose if I ask you significant figures. Actually, significant figures are not that important, but you have to remember them also. Significant figures, nothing but significant figures. Significant figures are nothing but number of digits. Number of digits. Clear? Okay. Very important thing I will tell you. If it is a whole number or if it is a decimal number, 0 before number are not significant figures. For suppose 007, you don't have to count this and this. Okay, you don't have to count this and this. For suppose 0.013, you don't have to count this 0 and this 0, because before number you have zeros. In decimal number also and in whole number also. Before number you have zeros. You don't have to count. So what is the significant figure? You have to count this only. So 1. Here you have to count these 2 only. 2. Clear? So number of digits here you have 2. Here number of digits 1. For suppose after number there is a 0. And in decimal also after number there is a 0. In this case, if it is a whole number, so if after 0, if there is no number, then you don't have to count this. But in decimal, always, if there is a 0, after 0 there is no number, but still it counts. Still it counts. Clear? Okay. So number of digits here 2, number of digits here 1. Here 1. Clear? Okay. Next, for suppose if I provide you a name or symbol. For suppose if I say Planck's constant, don't write the number. I'm just providing Planck's constant. I'm not providing the number to you. Just I'm giving you name. So whenever you see this name Planck's, that means this has infinite significant figures. For suppose if I say Avogadro number, I'm just providing you name. Whenever you have name, that means infinite significant figures. For suppose if I say one pen, that means pen means symbol, infinite significant figures. Okay, 777, 3 digits are there, so 3 significant figures. 55, 2 significant figures. Actually, this is not that important, but still I taught you. Okay, right. Next, next important thing, very important thing. Now we are going into the main lecture. We are going into the main lecture. So I will try to provide you some important formulas, because in physical chemistry generally we focus much on formulas, because whenever we prepare for objective examinations we go in one way. Whenever we prepare for subjective examinations, we go in other way. We are preparing for objective examinations. Our main goal is to solve the questions. That's why if any theory required, then definitely I will explain you. If theory is not required to do the questions, in that case, I will provide you only formulas. Clear? Okay. First of all, you have to remember one thing here. For suppose mole concept, here the first fundamental one is mole concept. Okay, so mole concept. Here, one mole, for suppose if I take example, I'm taking carbonate. I'm taking carbonate. Okay, if you take atom here, you have to report in atom. If you take molecule here, you have to report in molecule. Okay, right. So the first fundamental thing you have to remember, this is the mantra. So 1 mole of carbon atom. 1 mole of carbon atom. For suppose, if I take 1 carbon atom, it is okay. 1 mole of carbon atom means in 1 mole, you have Avogadro number of atoms, Avogadro number of carbon atoms. Clear? So 1 mole of carbon atom equal to 1 mole of carbon atom equal to Avogadro number of atoms. Avogadro number of carbon atoms. Avogadro number of carbon atoms. Right? So this Avogadro number of carbon atoms is equal to weight in grams. That is carbon 6 atomic number, 12 mass number. Because this is the higher abundance mass. So 12. That means which is equal to 12 grams of carbon atom. Because here I am taking atom. So you have to report here atom. 12 grams of carbon atom. 12 grams of carbon atom, right, which is equal to 22.4 liters at STP. 22.4 liters at STP. Okay, just remember this one, and I will provide you so many other formulas also, but try to do questions or solve questions by yourself by using this one in maximum cases. In maximum cases. Okay, right. Next important formula, one important formula. We do one thing. We do questions, and by doing the questions, we can see the formulas. Right? Okay. So first example. For suppose if I am taking 3.011, I am giving you 3.011 into 10 to the power of 21 molecules of water. Molecules of water. 3.011 into 10 to the power of 21 molecules of water present in vessel. Present in vessel or a container. Present in vessel or a container. Then I am asking you to provide number of moles of water. Number of moles of water. Number of moles of water. How can you do this question? Simple. If you want, I will provide you direct formula here. So you have molecules, okay, and asking to provide number of moles here. Asking to provide number of moles here. So one formula we have, that is number of moles equal to number of molecules or number of entities. Entities means atoms, molecules, ions, anything. So number of entities I can write. So number of entities means in place of entities we can put molecules, atoms, ions, anything according to the question. Number of entities by Avogadro number. Avogadro number. What is Avogadro number? Avogadro number equal to 6.022 into 10 to the power of 23 units per mole. Always write units while doing the questions. Don't forget to present your units. Okay? Right. So now according to the question, I have to solve this number of moles of water. So I have to solve number of moles of water. That means N is representing number of moles. Here water, number of moles of water equal to number of molecules of water present in a vessel given 3.011 into 10 to the power of 21. These are number of molecules, no units, because number of molecules over Avogadro number. Over Avogadro number. So Avogadro number, that is, for simple calculation, I am writing this as 3. Okay, for simple calculation, I'm writing Avogadro number as 6 into 10 to the power of 23 per mole. Okay, right. 3 2 ja 6, 10 to the power of 21, 21 minus 23. That means 10 power minus 2. So 1 by 2 into 10 to the power of minus 2 here per mole. So in numerator it is mole. So number of moles, that means 1 by 2 into 10 power minus 2. That means I can write 10 by 2 into 10 to the power of minus 3. Clear? Because this is 0.5. 1 by 2 is nothing but 0.5. 0.5 into 10 to the power of minus 2 mole. Right? Okay. Left, if this decimal will move to left, plus. If this decimal will move to right, minus. So minus 1, you have to add minus 1. So 5 into 10 to the power of minus 3 mole. This is the answer. So the number of moles of water in vessel is 5 into 10 power minus 3 mole. You have to remember this formula. Right? This formula is very, very important. Whenever examiner is giving number of molecules or number of atoms or number of ions and asking to calculate number of moles, you have to use this formula. Number of moles equal to number of molecules by Avogadro number. By using this also, you can do. Right? So for suppose if you take 1 mole of water. Okay. So 1 mole of water, how many number of moles? Okay. You have to take weight. You have to calculate number of moles equal to weight by molecular weight. Okay. So you will get number of moles. So it will take a lot of time. But if you remember this formula, you can easily do by using this formula. Right? Okay. Next one. Another important formula. Number of moles equal to. Okay, we have several formulas to calculate the number of moles based on the given data. So one formula I have already written, number of moles equal to number of molecules or number of entities by Avogadro number. Second formula, number of moles equal to, represent N, number of moles equal to given weight by molecular weight. Given weight by molecular weight. For suppose it is a molecule, or if atomic weight given, you have to take atomic weight. Clear? So number of moles equal to weight by molecular weight or atomic weight. This weight is in grams. Clear? So weight by molecular weight. Next, for suppose if I ask you to calculate the mass, okay, you have to rearrange this formula. If I want molecular weight, you have to take molecular weight here, N here. So weight by number of moles. Okay. So if I want weight or mass, number of moles into molecular weight, so I can write mass in grams equal to number of moles into molecular weight. So by rearranging this formula, I can get this one. Okay, just remember this. Okay, right. Next, for suppose if I give you one question, how many molecules of glucose present in 1.8 grams of glucose. 1.8 grams of glucose. So mass given 1.8 grams of glucose, how many molecules of glucose present? Okay. How can you do this question? Can you think? How can you do this question? Very, very easy. If you remember the formula. I want to calculate number of molecules. Now number of molecules equal to number of moles into Avogadro number. Number of molecule equal to number of moles into Avogadro number. One formula is there, right? So you have one formula, another formula. Number of molecules equal to number of moles into Avogadro number. You can do this question by using this. Okay, if you calculate number of moles and if you multiply this number of moles with Avogadro number, then you will get the number of molecules. Why? Because number of moles is nothing but mole units. Avogadro number per mole. Mole per mole get cancelled. Number of molecules unitless. So you will get your value in unitless. So you will get number of molecules. For suppose, so I have to calculate first of all number of moles. Here mass given. So number of moles equal to mass by molar mass or weight by molecular weight. Yes or no? Yes. So number of moles equal to given weight is 1.8 grams. 1.8 grams and molecular weight of glucose. Molecular weight of glucose C6H12O6, that is 180 molecular weight, so gram per mole. So gram get cancelled, gram get cancelled. Then you will get, if you find out this, 10 power minus 2 mole. Clear? 10 power minus 2 mole. Then now take number of moles as 10 power minus 2. 10 power minus 2 mole and Na Avogadro number per mole 6.022 10 to the power 23 per mole. Per mole get cancelled. Then my answer is 10 power minus 2 into Na. These are the number of molecules. So this many molecules of glucose present in the container. Clear? Otherwise, I can do this same question by using two formulas given already. How? See, so one formula to provide mole, to calculate mole is this. Another formula, number of moles equal to number of molecules or number of entities by Avogadro number. Okay, just equal them. Weight by molecular weight. This is the number of moles formula. Another number of moles formula, that is number of molecules I am representing as N by Avogadro number. Okay, just equal them. So here weight 1.8 grams over 180 gram per mole equal to number of molecules of glucose. I have to calculate. So N by Avogadro number. By Avogadro number. So this value is 10 power minus 2. Here Na. So 10 power minus 2 Na equal to N, number of molecules. So this is the answer. Okay. This is method 2. This is method 1. Okay. So this formula is very, very important. Number of molecules equal to number of moles into Avogadro number. Right? Okay. Next. For suppose, if I provide you N2 molecule. Okay. For suppose, just I will try to provide you one molecule here. For suppose AXBY molecule. Okay, AXBY molecule, and I am asking to calculate number of A atoms in this. Number of A atoms in this. Then what you have to do? First of all, you have to find out number of molecules. Number of molecules by using formulas given by using formulas by providing by providing the formulas. Right? You have to calculate by providing the formulas. So after calculating this number of molecules, so number of A atoms, that means you have to calculate number of atoms of A. How many number of atoms of A are presenting in this molecule? What you have to do? You have to take this coefficient. So this coefficient X into number of molecules. Okay. Number of B atoms. How many number of B atoms are present? Then coefficient Y into number of molecules. Okay. How many number of total atoms? Number of total atoms present in the molecule. Then here coefficient X for A atoms, for B atoms Y, X plus Y into number of molecules. Clear? Okay. For example, I am taking water. Right? I am taking water molecule. Okay. Here number of A atoms means number of hydrogen atoms. So how many number of hydrogen atoms are present in this molecule? How many number of hydrogen atoms are present? So here coefficient of hydrogen 2 into number of molecules. Number of molecules, clear? Number of molecules, okay. How many number of oxygen atoms are present? How many number of oxygen atoms are present? Again, you have to take the coefficient of 1, that is 1 into number of molecules. Total number of atoms present in the molecule, that means 1 plus 2, 3 into number of molecules. Clear? Clear or not? Okay. For suppose, I am providing you one example here. How many hydrogen atoms present in 1.8 grams glucose C6H12O6? How many hydrogen atoms present in 1.8 grams of glucose? Okay, so to predict this number of hydrogen atoms, first of all, you have to have number of molecules. You have to count number of molecules. So number of molecules equal to number of moles into Avogadro number, right? So you have to calculate mole first. So mole equal to 1.8 weight by molecular weight, 1.8 by 180, that is 10 power minus 2 mole, right? Into Avogadro number, that is equal to number of molecules. So number of molecules equal to number of mole into Avogadro number. So this many number of molecules are there. Now this many number of molecules into coefficient of hydrogen. In this, the coefficient is 12 because hydrogen atoms are 12 here. So answer is 12 into 10 power minus 2, and here this many hydrogen atoms are present in this. If I ask you to calculate how many number of carbon atoms, then you have to take 6. So 6 into 10 power minus 2, and here total atoms 12, 6 plus 6 12, 24. So 24 into 10 power minus 2, and here this many number of total atoms are present, right? So you have to calculate like this. Okay, these formulas are important. Okay, right. Next one. After this, just wait for a 1 minute. Okay. For suppose, if I ask you one theoretical question, sulfur molecule exists under various conditions as S8, S4, S6, S2, S. Okay, so first option, which option is correct? You have to tell. Mass of 1 mole of each of these is same. So the first one, mass of 1 mole of each of these is same. For suppose 1 mole of S8, 1 mole S8, 1 mole S4, 1 mole S6, 1 mole S2, 1 mole S. This mass of 1 mole is same? No. Why? Because here number of atoms are different. Because 8 sulfur 16 plus 16 32 mass. So 8 into 32. So mass different. 4 into 32, 6 into 32, 2 into 32. Here 32. So mass is not same. Number of molecules in 1 mole of each of these is same. Number of molecules is same. Number of molecules of every molecule is same. Yes, number of molecules is same. Why? 1 mole equal to Avogadro number of molecules. 1 mole equal to Avogadro number of molecules. So for everything, Avogadro number of S8 molecules are there. Avogadro number of S4, Avogadro number of S6, Avogadro number of S2, Avogadro number of S. So number of molecules in 1 mole of each of these is same. That is the correct option. Number of atoms in 1 mole of each of these is same. No. 1 mole which is equal to S8 molecule. S8 molecule. So number of molecules of S8, Avogadro number of molecules, into number of atoms, 8 atoms, so 8 Na. For suppose if I take S4, Avogadro number of molecules, and Avogadro number of molecules, and here S4, so 4 Na. This many number of atoms are there. Yes, so this is also different, right? So you have to do like this. Clear? Okay. One more important question. For suppose if I provide you 4 grams of NaOH. Molecular mass of NaOH is 40 gram per mole. Contain same number of sodium ions as are presented. Contain same number of sodium ions as are presented. Present in. Okay. Right. For suppose if you take first one, so here 4 grams of NaOH and 40 grams. What is the mole? Weight by molecular weight 4 by 40. That is 4 by 40, 1 by 10, 0.1 mole. Right? So molecules of NaOH, molecules equal to number of moles into Avogadro number. This is number of molecules of NaOH. Right? So number of sodium atoms. So only one sodium atom in this molecule. So number of molecules 0.1 into Na into number of atoms 1. So 10 power minus 1 Na. So given data, giving the answer as 10 power minus 1 Na. 10 power minus 1 Na. Okay. So for suppose if I give this option 100 ml 0.5 molar H2SO4. H2SO4. Then calculate number of moles. How to calculate? So one formula is there. Concentration equal to number of moles by volume. Concentration equal to or molarity equal to number of moles by volume. Number of moles equal to molarity into volume. Right? So here volume given, molarity given. Molarity into volume, number of moles. So number of moles equal to 0.5 into 100. Here ml. We have to take in liters into 10 power minus 3 liters. How? 1 liter equal to 1000 ml. 1 ml equal to 1 by 1000 liter. 1 by 1000 means 10 power minus 3. So 100 into 10 power minus 3 liters. Clear? So you will get 0.5 into this. If you calculate this, then you will get 5 into 10 power minus 2 mole. So this is mole. Clear? So number of molecules equal to number of moles into Avogadro number. These are the number of molecules. Right? So number of sodium atoms. How many sodium atoms are there in NaOH? That is 1. So how many sodium atoms are there? Sorry, just wait. This is not H2SO4. This is Na2SO4. How many sodium atoms are there? 2 sodium atoms are there. 2 sodium atoms are there. These are number of molecules. So 2 into 5 into 10 power minus 2 into Avogadro number. This many atoms are there. If you calculate this, you will get 1 into 10 power minus 1 Na. That means 10 power minus 1 Na. So this and this are same. This and this are same. So this is the option given. So by giving the data, you are getting this 10 power minus 1 Na, and in options, this one is giving same 10 power minus 1 Na. So the question is contains same number of sodium ions present in. So same number of sodium ions present in this 100 ml 0.4 molar 5 molar Na2SO4. Clear? Okay. So this is about this class. So I'm stopping this class here. This is the part 1 video. Okay, this is part 1. I will try to provide you part 2 as soon as possible. Okay, so that's all. Thank you so much.